In this video, we will talk about rationalizing denominators. And there are two situations where the denominator is formed by one term, like if you look here, square root of 3, cube root of x, square root of 5, cube root of x squared. This one is also one term. Or if we have two terms, like here. So let's begin. To rationalize denominators means to get rid of the radicals from the denominator. So our goal is to not have radicals at the denominator anymore. So let's take a look at example 1. We have 2 over square root of 3. So obviously we have a radical of 3 at the denominator. What can we do so that we don't change our problem, but the denominator becomes not a radical anymore? So I am going to multiply by square root of 3 over square root of 3, which means 1, right? So I'm not changing the problem. Now, square root of 3 times square root of 3, this denominator, we know that square root of 3 times square root of 3, it's square root of 9, which is 3. And if we multiply the numerators, because we are actually multiplying two fractions, so we multiply them across, the result is 2 square root of 3 over 3, so goal was attained. No more radicals at the denominator. So now looking at example 2, we have 3 over square root of 5. So what should we multiply by to get rid of the denominator or the radical at the denominator? We multiply by square root of 5, because square root of 5 times square root of 5 is just 5. And the numerator is 3 square root of 5. So again, radical, no more radical at the denominator. Now, if we take a look at example 3, well, this time we have 4 over cube root of x. So if we follow the same thing that we did before, let me just see, what if we multiply by cube root of x over cube root of x, like we multiply the denominator by the same thing? Well, what will happen is the denominator is going to be cube root of x times x, and I don't even care what it is at the numerator, because I just want to have this conversation first. So x times x, it's x squared. So we notice that we cannot simplify this further, so I cannot get rid of the radical from the denominator if we multiply by cube root of x. But we know, right, we know that cube root of x to the third, it's actually x, right? So the goal would be, if I could make the denominator, so that option was not good, right? So going back to, we know that it has to be a cube root, but I have here x to the first. So to make it x to the third, I will have to multiply by cube root of x to the second, because that will make it x to the third. So then we multiply by cube root of x to the second over cube root of x to the second. So the numerator is 4 cube root of x to the second, while the denominator is cube root of x times x to the second, which is x to the third. So cube root of x to the third is just x, and 4 cube root of x squared. So final answer. No more radical at the denominator. Let's take a look at example 4. So example 4, we have 5 over cube root of x squared. So again, because it's cube root, my goal is to have cube root of x to the third, because that is actually x. So we will have to multiply the fraction by cube root of x, because x to the second times x, it's x to the third. So we multiply by cube root of x over cube root of x, which means 5 cube root of x over cube root of x to the third. So one more step, 5 cube root of x over x. No more radical at the denominator. So just having this, let me make up an example 4 star. If you have, for example, 1 over 7 root of x to the third, for example, I want you to pause the video and think about it. What would you multiply by to get rid of the radical from the denominator? Well, I hope you have an idea, but let's think a little bit what's our goal, right? The goal would be to have 7 root of x to the 7 because that gives us x. But we have only x to the third, so we should multiply by 7 root x to the fourth because 3 plus 4 gives us 7. And so we multiply top bottom because otherwise we would change our problem. So looking at problem 4 star, this gives us 7 root of x to the 4 over x, and it's done. So very important in dealing with radicals are properties of exponents. So make sure you know what x to the n times x to the m equals. You know what x to the n over x to the m equals. You know what x to n over m equals as a radical, or what is m root of x to the n. All right, now let's take a look at example 5. Example 5, it's a little bit different than the other ones because it has a deep root, a root that covers the numerator and the denominator. But we learned the property in this class which said n root of a over b can be separated n root of a over n root of b. So this is what we're going to do in this case. So it's going to be cube root of 64 over cube root of x. But cube root of 64 is 4 because 4 times 4 times 4 is 64 over cube root of x. So now having this denominator, let's try to multiply so that we get rid of the radical. So again, our goal would be to have cube root of x to the third. So we would need an x to the second because I already have an x to the first. And cube root of x to the second. Now when we multiply across, this is the formula. When we multiply across, we get 4 cube root of x to the second over x, and mission accomplished. So now let's take a look at how we would rationalize denominators when we have more than one term. So before we do this one, so we are thinking what should we multiply this denominator by to get rid of the radical. So before we do that, let's take a look at what these products equal to. And we did this in the previous lesson. If I have a minus b times a plus b, it's a squared minus b squared. So in our case, looking at this example, we can immediately say that multiplying this gives us 2 squared minus square root of 3 squared, which would be 4 minus 3, and it's 1. Let's take a look at the second one. We have 5 plus 2 square root of 5 minus 2 square root of 5. So it would mean 5 to the second minus 2 square root of 5 squared. So that is 25 minus 4 times 5, 20, so it's 5. So again, looking at this, we notice that we started with radicals, but we ended up with numbers without radicals. We started with radicals, we ended up with whole numbers or sometimes even integers. So having this information, the fact that if I have a minus b and if I multiply with a plus b, I'm going to square each term, so get rid of the radicals. Or if I have a plus b and I want to multiply by a minus b, I'm going to eliminate radicals. So in other words, if we take a look at example 5, I have square root of 2 minus 1, so I should multiply by square root of 2 plus 1, top and bottom, and let's put parentheses around it. Because now the denominator is going to be square root of 2 squared minus 1 squared, right? A minus b times a plus b, it's a squared minus b squared. And the numerator is negative 3 times the quantity of square root of 2 plus 1. If you don't put the parentheses around your terms, you will not get the correct answers. So at the denominator, we get 2 minus 1, and at the numerator, we keep the product for a little bit, because sometimes if you have it in factor form, you can cancel it with some denominator. In this case, the denominator is 1, so all we do is just say negative 3 times square root of 2 plus 1, final answer. So if we take a look at example 6, that's right, we're going to multiply by 3 minus square root of 5 and 3 minus square root of 5, top bottom, right? Because we already have a plus b, so we need a minus b. So that means the denominator is going to be 3 squared minus square root of 5 squared, and the numerator is 8 times the quantity 3 minus square root of 5. Do not multiply the 8 just yet, and you'll see in a few seconds why. We get at the denominator 9 minus 5, so it means 8 times 3 minus square root of 5 over 4, right? So we can immediately say that because we have multiplication here, 8 divided by 4, it's 2, so the final answer is 2 times 3 minus square root of 5. While if you multiply, you might not notice that you have common factors. Let's take a look at 7. So here again, the denominator is square root of x minus 6. Let's multiply by square root of x plus 6. And so the denominator is square root of x squared minus 6 squared. And the numerator, it has these terms and it has these terms. Make sure you put them in parentheses because you want to make sure you are multiplying the whole numerator by the whole numerator of the second fraction. So we leave it 10 minus square root of x times square root of x plus 6 over, and the denominator is x minus 36. It seems like I don't have common factors. We can multiply if we want at the top, but we cannot get a better answer. So if I multiply, I would get 10 square root of x plus 60 minus x minus 6 square root of x, yes, over x minus 36. And I do have like terms of 4 square root of x plus 60 minus x over x minus 36. Pretty much that's it. There is no more common factors. All right, and let's do a fun one. Example 8. So example 8, we do have square root of x minus square root of y, so we will multiply by square root of x plus square root of y, top and bottom. So when we multiply, the top is going to be x squared minus y squared times square root of x plus square root of y, right? I just multiply the numerators, but make sure you put parentheses around it because they are the terms contain, each factor contains more than one term, and then square root of x squared, which is x, minus square root of y squared, which is y. Now at the numerator, I see this x squared minus y squared, which we've used today, but we use it, like now we have to factor it. Before we had to multiply. So we have x minus y times x plus y times square root of x plus square root of y, everything over x minus y. So we can see how this quantity cancels with this one. We get 1. So then the final answer is x plus y times square root of x plus square root of y. No more radicals at the denominator. So I want to emphasize how important it is to not multiply the numerators before you check if you have any common factors between them. Because if you actually multiply these two before noticing that this can be factored further into these two, you would never get this final answer. I hope this helps.